All right, let's dive straight into the world of numbers. If you're in CBSE Class 9, you're in exactly the right place. We're going to take a journey through Chapter 1, Number Systems. And trust me, we're going to make it all make perfect sense. So let's get started. So where are we headed? Think of this as our roadmap. We've got 5 main stops. First, we'll kick things off with the journey of numbers itself. Then we'll stumble upon some mysterious, irrational numbers. After that, we'll crack the secret code of decimals, get our hands on a couple of really useful tools, and finally, we'll wrap it all up by seeing how our number line gets totally complete. Okay, first stop, I want you to picture this. You're standing on a giant, endless number line, and you're holding an empty bag. Our mission is to walk along this line and collect every single type of number we can find. The whole key to cracking this chapter is this one simple idea. We're going to start with the absolute basics. I mean, the very first numbers you ever learned when you were a little kid. So as we start walking down this number line, what do you think is the first thing we're going to grab and put on our bag? You got it. It's the counting numbers 1, 2, 3, 4, and they just keep on going forever, right? All the way to infinity. In math, we call these guys the natural numbers. So boom, into the bag they go. Wait a second. Hold on. Did you see that? We walked right past a super important number. We forgot 0. Let's back up, scoop it up, and toss it in the bag. And you know what? The second we add 0, our collection gets a whole new name. It's not just natural numbers anymore. Now we've got the whole numbers. Okay, now turn around and look at the other side of the number line, to the left of 0. There's this whole other universe of negative numbers just sitting there. -1, -2, -3. Let's grab all of them too. Now our bag is getting pretty full. We've got all the positives, all the negatives, and 0. This entire collection, that's what we call the integers. And hey, here's a cool little piece of trivia for you. Ever wondered why we use the letter Z for integers instead of I? Well, it actually comes from the German word Zahlen, which simply means to count. Kinda neat, right? But hold on, our number line isn't just about hopping from one whole number to the next. What about all that space in between? You know, numbers like 1/2 or 3/4, or even -5/7, all those fractions. Any number that you can write in that P over Q form, let's sweep all of those into our bag. And here's the real kicker. Every single number we've already collected, even an integer like 3, is also a rational number, because you can just write it as 3 over 1. So everything in our bag right now fits under one giant umbrella, the rational numbers. So our bag is packed, absolutely overflowing with rational numbers. We must be done, right? We've collected every number that exists. Or have we? So let me ask you this directly. Take a good, hard look at that number line in your mind. Is it totally, completely filled up now? Are there any tiny little gaps left? Or did we maybe miss something along the way? And here's the mind-blowing part. The answer is no, we're not done. There are still an infinite number of points on that line that we haven't picked up yet. These are the weird, mysterious numbers that you just can't write as a simple fraction. And they have their own name, irrational numbers. They're a whole different beast. You know, the history behind this is pretty wild. Way back around 400 BC, the followers of Pythagoras, the triangle guy, they believed the entire universe was built on nice, neat, predictable fractions. So when they stumbled upon a number like the square root of 2, it totally freaked them out. They couldn't believe a number could exist that didn't fit their perfect system. It literally shattered their whole worldview. Okay, so we have these 2 huge groups of numbers now, the rationals and the irrationals. But how on earth do you tell them apart? Well, there's a secret, and it's all hidden in their decimal expansions. Let's break it down. A rational number's decimal will always do one of 2 things. Either it stops, it terminates, like 1/2 is just 0.5, and that's it. Or it goes on forever, but in a nice, neat repeating pattern. Irrational numbers, though, they're the rebels. Their decimals, like for the square root of 2, go on forever and never repeat. There's no pattern at all. It's just a chaotic, endless stream of digits. That is the dead giveaway. All right, so now we can spot the difference. That's a huge step. But what about actually using these numbers in calculations? Let's gear up with a couple of super useful tools that'll make working with them way, way easier. You've probably seen something like 1 over the square root of 7. It just looks messy, doesn't it? It's kind of clumsy to work with. Well, there's a really neat trick called rationalizing the denominator. All it means is we're going to clean up the bottom of that fraction. And it's so simple. You just multiply the top and the bottom by that same square root. So we multiply by root 7 over root 7. On top, we get the square root of 7. On the bottom, root 7 times itself is just 7. And there you have it. The denominator is a nice, clean, rational number now. So much better. Our next tool is an absolute game changer. I'm talking about the laws of exponents. Think of these as the cheat codes for dealing with powers. They're just simple shortcuts. If you're multiplying with the same base, you just add the exponents. Dividing, subtract them. A power raised to another power, multiply them. And if the bases are different, but the exponent is the same, you can group the bases together first. Seriously, learn these rules and you'll feel like a math superhero. Let's put one to the test. How would you solve 7 to the power of a half times 8 to the power of a half? Looks tough, right? But check out that last rule we just saw. The exponents are the same. They're both a half. So all we have to do is multiply the bases together first. 7 times 8 is 56. So the answer is simply 56 to the power of a half. See how that rule made a tricky problem super easy? Okay, we've reached the final stop on our journey. It's time to take a step back, look at everything we've collected, and see how it all comes together to complete the picture. Remember that bag we've been carrying? We had all the rational numbers in there. And then we found that whole separate collection of irrational numbers. So what happens when we dump them both into the bag? We get the whole shebang, the complete set. And this is what we call the real numbers. And now, finally, our number line is truly complete. There are no gaps left. Every single point on that line is a real number. But that leaves us with one final fascinating question. We've filled the number line, so is that it? Is that the end of the story for numbers? Or, just maybe, is there something else out there beyond the real numbers? Something even stranger, just waiting to be discovered? It's definitely something to think about.